Welcome to the Generic Tech Support YouTube channel. Like and subscribe for more content. Welcome to Fedora. But today's video isn't specifically for Fedora, but Fedora was necessary in making this video. You see, Microsoft developed and released its own Linux operating system. They kind of did this on the hush-hush. However, it was released in order to be used on Azure. And there's kind of a reason behind that. You see, all these containerization products, they've all been developed in Linux, and they don't work on Windows. And since these products are based on efficiency and application deployment, Microsoft really wanted to get in on this. As a result, they developed their own Linux product to be hosted on the Microsoft Azure cloud. The thing is that while it is a Microsoft product, and it is a homegrown or self-developed product, it does run traditional configuration file standards. These configuration styles, they align with Fedora. These are things such as the DNF and RPM structure. This is different than Debian, which runs the .deb and the apt configuration. As such, to mimic the configuration protocol, I decided to use Fedora. So today, I think we should take a look at Kubernetes. And to save time for everybody, I developed a lab script, which will be on the Generic Tech Support website. The lab script configuration will give you the ability to install Kubernetes without having to do any real configuration. This will allow you to stand it up, test it out in a lab scenario, and see how it works for you. Or, if you want to use it in a production commercial environment, you just have to modify the scripts to allow you to do so. Ultimately, this should save you time either way. Let's start with some prerequisites. Much like Debian, Fedora still uses the same kind of update protocol. So rather than doing sudo apt update, in Fedora we'll do sudo dnf update and then hit enter. Make sure you update your Fedora before you install this package. The nice thing about Fedora is it actually outputs the process. So as we can see here, it tells you specifically what the update is and the size. At this point, we could hit Y on the keyboard and hit enter. And you'll see that it will download the number, the variable, and the amount of data that it has downloaded. I always like to start with a clean cursor. So let's do clear and hit enter. Next, I want to install Z, or XED. Z is a text editor. This is actually the built-in text pad or notepad looking application that comes in Mint. I'm really not a fan of the way things look inside of Fedora, so I decided I would install the Mint text pad. That's specifically XED, and to install it, just do sudo dnf install XED space -y and hit enter. You can see on my system, I already have it installed. It'll tell you if it's already installed by saying nothing to do. Let's start the configuration of our Kubernetes. For the sake of my Fedora system, I created a folder called K8s. You could call it anything you want. It doesn't make any difference in the script configuration. In that folder, I have 4 files. The .sh files can be run in bash. The YAML file, which is basically just a fancy configuration file, is required by the installer during the install process. The actual installer here will call the YAML file. If we open the YAML file and edit it, we're going to do open with. We'll choose the text editor and we'll make sure that it's set to always use this file. If not, the default app will use the default text editor. Again, it's preference, but for me, I prefer the one that was in Linux Mint. And then click open. In the YAML file, you're going to see things like name. Now you can modify this and make this something custom if this is not a lab. If it is a lab, then just leave it alone. The reason why is there'll be additional configuration in the future that you'll have to change in other scripts if you change this name. This is the install script that I created. It's very high level. See, recently I did a side contract, and during the side contract, I went through a configuration of Kubernetes and Docker. In the Kubernetes configuration, I decided that I was going to use a script to do the installation. And what I did is I modified and shortened the script for a lab configuration, so that way they could run an internal lab. I then doctored the original script that was used for the lab and created this script to do the installation process. I want to share these scripts with you, so that way you could do them to set yourself up with a lab, so you could learn Kubernetes as well. While it would be helpful to have more than one system, so you could learn the clustering side of it, it's not necessary. It does work in VMware. So you could run VMware Workstation and have multiple VMs running your cluster. That would require modification of this script, as well as your configuration files. However, since this was created to do it as a simple process, I'm going to walk you through the installation. So the installation starts with disabling the swap file. That's required in Kubernetes. To fully disable it in Fedora, you're going to be required to do a reboot. I would suggest what you do is run this script, and then when you're done, go in here, modify the script, add the hash value, put a space, and comment out the reboot command. Then save the script and run it again. On the second run through, after saving this configuration change, The system will run through this again. However, it'll give an indication that there's nothing to do. Let's start the installation process by running the first part. To run the script, I would suggest doing bash, then the name of the script without the sudo command in the beginning. Because not every step in the actual script requires root access, you don't want to use sudo before the actual bash command. You'll notice that the K8s folder that we're in, the repository, matches the K8s above. You'll have to change directory or CD to this location, or simply in this folder or whatever folder you add the scripts to, right-click and choose Open in Console. Once you're ready to execute the script, hit Enter on your keyboard. You'll be prompted to enter your password. Enter your sudo password and hit Enter on your keyboard. You'll notice that this is going to attempt to do an installation, and it's going to indicate that it has to do a change. You'll have to hit Y to continue. Once you do, the system will reboot itself. Once the system comes back up, just log back into the system as usual. Go back to File Explorer where you have your script saved and right-click and choose Open in Console. Before you enter anything in the console again, make sure you go back into the installer and edit it with the text editor. You'll need to modify that one line now to add the hash value before the sudo reboot now so the system doesn't reboot again, and save. At which point you could close your text editor. However, for the sake of this video, we should go through what the next process and procedure is in the installation. Now, I hashed all of these statements out indicating what each one does in the actual config. However, while I try to be organized, sometimes errors occur in a script, and I do make modifications to them without adding the actual information as to what occurred or what takes place. I might fix this before I publish the script. However, for the sake of argument, the next thing we're going to do is do an update to make sure the system's up to date. Now, if you updated before you ran through this, presumably there shouldn't be much in here in the forms of updates. The next thing we're going to do is we're going to disable the firewall. Now, keep in mind that if you're going to do this in a production environment, you would want to add the firewall configuration in here and keep the firewall running. However, since this is a lab, it's not necessary, and we're just going to disable the firewall. The next thing we're going to do is install IP tables. That's important, because if IP tables is not installed, then Kubernetes becomes a pain in the neck to configure from a network configuration standpoint. Next, we're going to add some customized configurations to the K8s configuration file. You'll see that here. Next, we're going to do some installation of kernel modules, and then we're going to restart the system to load those modules. Next, we're going to install CRI, and CRI is the runtime product that integrates the kubelets with the actual containers. So basically it ties the physical application handlers with the virtual application in the containers. Then we're going to enable these containers. If you think of systemctl, think of it like the services console inside of Microsoft. So basically you're restarting a service to implement the actual configuration changes. Because in Linux, it's a flat file system, so it's reading from a file. And if you make a change, you have to reread that file for that change to occur. In Windows, there's a lot of dynamic configuration involved, meaning that there's a pull, so the applications generally recycle themselves, and when they recycle themselves, they reread the config file. In Linux, that doesn't happen. Next, we're going to install the kubelets and the Kubernetes actual client. And when we do that, we're going to restart the service again to read from the configuration file to reload the data. At this point, my system threw an error. And I had to figure out what the error was. And I was missing configuration to my IP tables because I do have IPv6 enabled on this particular system. Rather than screwing with all the IP table settings and configuration, I just added additional data to the actual K8s config file, which you could see down here. Now, generally, I would say we should reload this configuration by adding another line, but it wasn't necessary because we're getting towards the end of the script and it does require a reboot for this to work. I added a failover for the swap file. The reason why I did that is because in the event that the above fails and the swap file is still running, we could force the swap file, at least for this particular session, to turn off, so that way we can install the rest of the Kubernetes configuration. I then go an extra step and say turn off the swap file after restart. So in the event that the swap file still stays on, after a reboot, it will shut itself off. I then restart the kernel configuration again to reload the system settings, because there were additional modifications that took place to the kernel above. Those modifications are required for us to run through the rest of this config, so it was necessary. At which point we grant access to the local account. So in my case, I'm using the Tor account, so we could see the configuration here for the Tor account to give myself access to the actual Kubernetes application. This is where we're going to install CNI and Flannel. This is the configuration that adds a network layer for the pods in a cluster. Again, probably not necessary for our single node configuration lab, but I included it. This is where we integrate in a single plane all of our cluster configuration. At this point here, Kubernetes is installed. However, we still need some form of access, and since we're talking about a single system to access this stuff, I included the configuration to install a web GUI. The one I decided to choose was Helm. If you don't like Helm, you could take from here down and just comment it out. They do make different configuration tools. You could use different web configurations. You would just have to Google them and figure out what they are. For the sake of my configuration, again, I used Helm. The Helm configuration is included in this script. You'll install the Helm dashboard. You'll do the Helm configuration with the YAML token. So we looked at the YAML configuration above when we looked at the original settings here. So that's the YAML file, and you'll see the YAML here. So if you change the name of that YAML file, you'll have to change the name of it here in the script. Once you finalize this configuration, it'll appear as though it's running. It will run temporarily before it reboots itself. When the system comes back up, at that point, we could tackle the next step in this procedure. However, before we do that, let's run this on our test system. Of course, once again, it's just bash the K8s fedora build installer.sh. You'll enter in your password for your Tor account or whatever your user account is, for your sudoer, and you'll hit enter on the keyboard. This may take some time to do the install, but it's a lot faster than if you had to do this manually in a step-by-step process. At times it may appear as though the script pauses. It just takes some time for it to do the config, so just be patient. Once the script finishes, the system will automatically reboot itself. It may appear that the script hangs again. This is common, just ignore it. At this point, the system is actually installed. However, you can't access it yet. The reason why is because our web portal isn't running. So we're gonna need to open two consoles on the actual system. Once again, just right-click somewhere in the folder where you have the actual scripts and choose Open in Console. Then right-click again and choose Open in Console. The first script you're gonna wanna run here is to start the GUI. To do that, you're going to simply type in bash space K8s dash GUI portal launcher and then hit enter on the keyboard. You're going to notice that we're now forwarding our local host configuration to port 8443. You're going to want to open up Firefox at this point and go to localhost :8443 under HTTPS. Now keep in mind, we don't have a certificate on this particular system, so you're going to get a warning that's going to flash across the screen. You can ignore it, hit the advanced button, and then accept the risk and continue. You'll notice that we can't log in without a token. This is where your other console comes into play. For this, you're going to want to run the K8 configuration to output the token, so the token generator, as we can see here, which is simply just bash K8s underscore token underscore generator.sh, and we're going to hit enter. You're going to see this is going to output a token. This token is the security token you're going to want to grab. Not want to add any additional space to the end of it. Right click, choose copy, go back over to your Kubernetes dashboard, right click, choose paste, and hit sign in. There's no point in saving the username and password because the token changes every time you launch the web portal. At this point, you have Kubernetes installed, and you can actually access it to play around with it. Hopefully this is super helpful for anybody that wants to set up a lab for Kubernetes. Importantly, you should note that Kubernetes is actually referred to as K8s on the internet. The reason behind that is because of the number of characters between the K and the S is the number 8. So K8s is what you're going to see if you Google it on the internet for more information. Kubernetes and K8s is the same product. So guys, this is where I leave you. Let me know if you have any questions. Thank you for watching the Generic Tech Support YouTube channel. Find the content of this video at https://generictechsupport.com/#channel.